So till yesterday, what we were discussing in the classes till yesterday, what we were discussing was the basic terminologies. We went through, or rather, we refreshed, or you rather just refreshed about what all you learned earlier also, namely the basic terminologies like charge, current, voltage, power, energy, and so on. And some questions, some problems, small problems were done. So as I told you yesterday, today we are going on to circuit elements. Instead of confining ourselves just to the basic terminologies, we are going to discuss about certain circuit elements. Even that you have already learned, but I hope you have done this homework problem. If there is any doubt, anyone can ask now. If you have not attempted, which is a more likely possibility, do it today. Okay. So circuit elements, even that is very much clear, known to you, but for the sake of starting the subject, I have to go through this. So circuit elements. As you all know, circuit elements are of two types. One is the passive elements and the other is active. Passive elements, by passive elements, what do you mean? Our resistance, inductance, capacitance, etc. Active elements are those which come in the circuit, which are usually capable of generating energy. Now, in my written notes, I have deliberately written exactly like this so that it is easier for you to correlate between my class video as well as the written notes. So even the format may look exact. I have done a work in that manner. Check whether it is easy for you to learn. Okay. So this capable of generating energy, by which I mean it can be a voltage source or a current source. Okay. And there can be one more classification. It can be an independent source or a dependent source. So I mean by this active element, usually what I mean is sources. Okay. An ideal independent source. That is the active element. I am speaking about the active elements. An ideal independent source is an active element that provides a specified voltage or current that is completely independent on other circuit elements. They just give you the required voltage or provide the required current, which is independent of other circuit elements. Whatever be the resistance there, whatever be the inductance there, whatever be the capacitance present in the circuit, this independent source will give you the voltage. If it is ideal, then it gives you the correct voltage that is mentioned. And this is how you indicate an ideal independent source. It's a voltage source that I'm talking about. You put plus, minus, and put a V. And this is another kind of representation. Another kind of representation. Plus, minus, capital V. Now, both of these are independent sources. Only difference is that one is a time varying, this is a time varying voltage source, and this is a constant voltage source. Again, current source will always be indicated like this, with a circle within which you will have an arrow mark indicating that it is a current source. This is a case of ideal independent source. Now, how will you represent them in a dependent source? Let's see how. How do you represent the dependent source? If it is a dependent source, ideal dependent source. What I mean by ideal dependent or independent source is whatever value is mentioned, that is there. There are within the battery also, you might have learned there are internal resistances where there can be some drop, etc. So that is not considered at all. I'm considering it as an independent source and a dependent source, ideal. So if it is a dependent voltage source, how do you draw that? You always draw with a rhombus kind of representation. Okay. So this is V with plus minus, and this is volt current. Again, that is also indicated by this kind of a representation, but an arrow mark indicated this is a case of an ideal dependent source. So just for the sake of understanding, that is why. So what is a dependent source? It is a controlled source, controlled one. That is, the source is an active source or active element, but the source quantity is controlled by some other voltage or some other current. So like as in the case of op-amp, etc. Now, the dependent sources can be of many types. What are the different types of dependent sources? One can be voltage control voltage source, or current controlled voltage source, or voltage controlled current source, or current control current source. So these two are current sources, these two are voltage sources. So they can be dependent on other circuit elements. So one example is your op-amp. Op-amp means operational amplifiers or transistors are there. They also are active elements depending on their biasing and all those things, which you will learn later. But they are active elements, but at the same time they are dependent elements. And also there are ICs, integrated circuits. All those come under active elements. Okay. This is just an introduction. Now coming to very important case. What is that? In electrical engineering, if you ask me, which are the two laws which govern the entire electrical engineering subjects, the basic or the fundamental laws, they can be taken as two laws. One is the very famous Ohm's law, and the other is Kirchhoff's laws. Kirchhoff's laws, two laws. So basic laws, one which you will learn as Ohm's law, the other is Kirchhoff's law. Now, first we'll start with Ohm's law. And again, you will be thinking I am going to very basic. But then there are certain things which I may trigger in your mind during this learning of the basic things. Okay, so materials in general, all materials in the nature or all substances, all materials have in general have a characteristic behavior. Characteristic behavior of resisting the flow of electrons, of resisting the flow of electric charge or electrons, electric charge. Okay, so now my discussion is now limited to Ohm's law only. Okay, Kirchhoff's law we'll look later on. Okay, and then that ability, that physical property of doing this is called as the resistance of that particular material, and you indicate it by R. And that resistance, as you all know, if this is the material that I am speaking about, if it has an area of cross section A, and if I am considering a length L of that material, and if the material has a property of resistivity rho ohm meter, then from the various measurements that have been done in the lab, scientists have come up with this formula where R is equal to rho L by A, which is actually measured in the lab. Okay, and good conductors like copper, aluminum, etc. As you all know, resistivity is very low. This is called as resistivity. Resistivity is very low, and for materials like mica, paper, etc., which are insulators, resistivity is very high. And we have been using this property of mica and paper, which are the insulators, having high resistivity, as we have been using this property of them to use them as dielectric. If you remember, use them as this property is being utilized by us and use them as dielectric capacitors. We'll go to that later on. But for now, I am restricting my talk again to resistance only. This circuit element, which is, this is only a physical property. All of you should understand this. This is not a major thing that you do not know. But one thing that I want to know from the point of engineering. Now, the physical property is the resistance. Okay. How do you model it? How do you represent it in a circuit? By using a resistor. So resistor is nothing but a circuit element which is used to model this property. Now you will think that why I am emphasizing on this, why I am saying this. We know that resistance and a resistor are no. You should know that if it is a power line that you're speaking about, you can always say that its property is our resistance. You should always understand that the major contribution of mankind towards technology is its mathematics. There are umpteen number of mathematical equation solving tools. So whatever you have as a problem, being first year students, I want to make this very clear to you. Whatever problems that you have in your engineering field, all engineering problems will be physical in nature. For example, there may be a problem with your transmission line. There may be a problem with the transformer. There may be a problem. But so how do you approach that problem? You cannot always do an experiment on the particular appliance and find out. You cannot, maybe you have a problem with your fan or the motor inside the fan. So what is your idea? That is a physical thing or a physical appliance there. You will have to reduce or you will have to change that physical appliance or physical body or physical device into its physical model. Okay, so you have I will go to, if you want any clarifications, tell me. This is very important. A problem solving approach. This is how you problem solving approach, which every engineering student or every engineer should have. Now, I am leading you through a path where you should understand why this is being done. Okay, so you have a physical device or appliance. Okay, and you are facing some problem with that device, be it a motor, be it a transformer, be it a transmission line, whatever. So how do you do that? You cannot do an experiment in the entire KSEB network and do. So what will you do? You will have to convert that into its physical model. What do you mean by the physical model? By physical model, what I mean is you have to convert it into the lumped parameters. Lumped parameters in the sense, I will have to convert it into R, L, C, etc. So here, this resistance, you are modeling, or the physical property of resistance is being modeled by this resistance. And so you will get a physical model in the form of network or circuit. Okay. Now the physical model will be converted into a mathematical model. How do you convert the physical model into a mathematical? Now you have the capacitance, inductance, etc., or network, etc. This is the physical model. And how do you convert that physical model into mathematical model? For that, you use the basic laws. In our electrical engineering, the basic laws are Ohm's law and Kirchhoff's law. Okay. Had this been Chau's laws. Had this physical device been a furnace, for example, you will be going for, instead of putting it in the sense of Lamont parameters like resistance, inductance, capacitance, I'll be putting it in the form of mass, its friction, and all those things. And I'll be, instead of using Ohm's law and Kirchhoff's law, I'll be using some D'Alembert's law or whatever mechanical laws in the mechanical engineering. So finally, what I am aiming at is to get a mathematical model. Now I am no longer bothered about the physical device, how it looks like, or how much dust is on that, or etc. What I am bothered about is only the mathematical model. Now, when I get the mathematical model, I can always have a number of mathematical number of tools in mathematics to solve and get an idea about the problem phase. Then I go back to the physical device. This is what an engineer or a designer or whoever it is doing. Basically, this is being done in your engineering. Hope you understood. Can anyone help? Can anyone tell me? Can anyone respond, please? Amit Prem. Amit. Oh God. Asmin.
Yes, ma'am.
Asmin, did you get an idea of what I am telling you? Am I going haywire?
Yes, ma'am, it's clear.
Is it clear? So what I wanted to emphasize is that you need a physical model, as well as you need some basic laws, so by which you can convert the physical model into the mathematical model. What do you mean by mathematical model? Mathematic equations, just the equations. You get the equations in the form of differential equations or algebraic equations. You can solve and find some answer and go back to the physical device. So if anyone asks you why you are learning all these things, all these subjects, and in those subjects you will never see any transformer as a transformer. In most cases you will go in for so many equations, and you will be bothered about, since you are first year students, I am just telling you all these things, and then you will appreciate why you are learning all these things. Now, all these equations are required once you are put into an arena where you require to solve electrical engineering problems. In electrical engineering problems, you will have to use the basic laws and come to the mathematical model. Now, resistor, or I told you the resistance is the modeling part of the property called resistance, and it is indicated by R, as you all know. If current is passing in this direction, you have a voltage drop, like, sorry. You put plus minus like this, and you have a voltage drop here. And resistor is the simplest passive element. Now, whatever I was talking to you previously may not be something that anyone will tell you. This comes out of your own, experience in this field. Okay, now I am coming to Ohm's law. It's time to stop the class, but I'll continue for 5 more minutes at least, because I got you also came into the class late. Okay, so Ohm's law, it states that the voltage across a resistor is directly proportional to the current flowing through the resistor, and that is V is proportional to I. Ohm is the name of the scientist. He defined the constant of proportionality as the resistor R. It's the constant of proportionality, and hence V is equal to IR. This is the mathematical form of Ohm's law. It is not the statement, mathematical form of Ohm's law. And if R is in Ohm, and you know R, the unit of R is ohms. And R is equal to V by I, that is 1 ohm is equal to 1 volt per ampere. Now, since it is since the value of R can take any value from 0 to infinity, we have to consider the two extreme possibilities of R. For example, if I am considering case 1, I have written the note just like that so that it will be easy for you. Case 1, if I am considering R is equal to 0, R is equal to 0 means what? I have a network and I am connecting the R is equal to 0 means what? Samayam kittanillalo. Navaneeth S, are you there? Navaneeth, I think everyone has gone for breakfast, is it? That is the problem when the second period class overlaps with the third. That's the problem. Navaneeth is there, whoever is there, please respond.
Ma'am.
Yeah.
When adding 0, ma'am.
Navaneeth, who is speaking?
No, ma'am. I'm Abhay.
Abhay.
Ma'am.
What do you mean by resistance 0?
It acts like a wire, just connecting wire.
Short circuit.
Yeah, short circuit.
Exactly. Okay, short circuit. Okay. So I have short circuited the terminals. Okay, which means this is R equal to 0. In which case V is equal to IR. R is 0. V also will be 0. That is what I want. The whole current flows through it. V will also become equal to 0. This is one condition. Now case 2. R is equal to infinity. I am considering both the extremities when R is equal to 0 and R is equal to infinity. R is equal to infinity means what is that? I'll be considering this thing. R is equal to infinity means what? Someone? Rishikesh? Open circuit. Okay, open circuit. So you cannot use this equation anymore because I is, you are going to find out the voltage there. And voltage is, you cannot find it like this because VR is infinity here. So what will you do? You will find it as like this. I is equal to, I am going to find out the current value of current. Obviously, you know what the value would be, but limit R tending to infinity, V by R equal to R tending to infinity, V by R 0. So no current. So which means this is also easy. Now, why did I mention these two? Whenever you do a problem in your future also, there are conditions where you will have to prove whatever equation that you have come with. This equation is Ohm's law. But how do the scientist called Ohm, make sure that his equation is correct? He'll have to go for finding out whether this equation is correct in both the extremities. That is when R is equal to 0 as well as R is equal to infinity. If this is true for all, then it is true for all conditions. That is how he can say that my equation is correct. Take it from me, I have evolved in one of my PhD works. I have come forward with a new equation, altogether new equation. And how do I prove that this equation is correct? I will prove this is correct for when it is the worst condition, and it is correct for the best condition as well, which means for all the conditions it is true. That is how you can say that the Ohm's law, V is equal to IR, is a correct equation. I hope you understand. I don't know if I'm going, is it okay? Someone, Varsha?
Yes, ma'am.
That is why I call you. Hey, Varsha, is this okay? Am I going haywire? Like, do you want me to explain? Is this okay? This kind of explanation? Okay. So, So Ohm's law is over. And now a resistor can be of two types. Resistor, the actual resistor, physical resistor can be either a fixed resistor, which you have seen in your labs, and can also be a variable resistor. Variable resistance will be like a rheostat and all other things. Okay. But one important thing that you have to remember is not all resistors obey Ohm's law. Ohm's law has its own limitations. If it obeys Ohm's law, it is called as a linear resistor. By the name itself, you should understand that its characteristics will be linear. If I draw a VI characteristic, because V is equal to IR, isn't it? So naturally, if it's a linear resistor, its curve will be like this, straight line, and its slope will be R. By this equation, isn't it? Then you can have non-linear resistors as well. If it is a non-linear resistor, as you will very much know, the characteristics will not be linear. It will be something like this. Maybe, as in the case of a diode. Example is a diode. It doesn't obey Ohm's law because the resistance is not. So you can know, this equation is self-explanatory. Only if it is V is equal to IR or a linear resistance curve, then it will obey. Then I am closing my class because your time is getting over. There's one more term that you should know, conductance. Conductance G is equal to 1 by R, or it is I by V. Instead of V by I, it's I by V. And unit is mho, which is denoted by this. People always also use Siemens as the unit, mho and Siemens. Whatever, 1 Siemens or 1 mho is equal to 1 ampere, as per this, 1 ampere per volt. Then the last thing that I want to say is the power dissipated. Power dissipated or power absorbed by a resistance. Resistance do not absorb it. Power dissipated as heat and light, etc. by a resistor is given by P is equal to VI. We already know that, which is equal to I squared R, which is also equal to V squared by R. With this, I am stopping the class today. I was planning to do more, but let me stop with this. This much for today. Any clarifications or anything that you need? Anyway, any doubt, any silly doubt can also be asked. That may not be silly. People think that some doubts are silly. You should remember that when I was doing my first year, first semester, first year, when we had S1, S2 together, I had lots of doubts. But I had a lot of hesitation to ask the teachers, because I always thought that all the doubts were silly. But then what happened is that when you go to the second year, the doubts you feel more hesitation. When you go to the third year, the hesitation is more. When you reach the fourth year, this doubt still remains, and you cannot ask the question, because people will always, then the teachers may think, you have reached the fourth year and still you do not know. So this is a cumulative action. Whatever doubts you have, it's always better to clear it then and there. I am a teacher who will always appreciate questioning me back. Maybe some doubts which you may think as silly doubts may not be silly at all. Maybe it will be a difficult question for me also. Don't think that what the teacher will think, what the others will think. Don't think so, because any doubt is a valuable doubt as far as I am concerned. So any clarifications or anything regarding this, or anything little bit external to this also, you can ask me. Okay, feel free to ask me. I'm always there to help you with all these things.
Ma'am.
Please.
Ma'am, superconductors resistance is 0.
Voltage
0
Sorry?
Voltage 0
Adila, I think we can discuss that in the next class also. I'm having a class 10:45 at the class on. Who asked? Ashwin? Ashwin? Who
Yes,
asked? Ashwin. I'll speak a little bit about that in the next class starting itself. Okay, Ashwin?
Okay, ma'am.
Very good question. Very good question. I'll come to that. It's a very important topic as of now. It's very relevant question also. Ashwin, I'll talk about that next class. Okay.